All right, so we're going to wrap up Chapter 5 with what's called the distance formula. Similar to what we've been doing, working with squares and square roots and right triangles. So we're given a picture of a graph, and then we've got a right triangle here with some reminders there about the right triangle properties. Basically what we're going to do is we're going to end up seeing some right triangles on some graphs today. So finding the distance on the coordinate plane, this is the easier one. You can use the Pythagorean theorem, a squared plus b squared equals c squared, and then to find the distance between 2 points on a coordinate plane. The easiest way I find when you're given a graph is to make a triangle, count the rise, and then the run, so that's the y and the x, and use the Pythagorean theorem to plug and chug. So we'll see that here on slide 3. So we're given a triangle here, graph the ordered pairs, 3, 0, done, 7, negative 5, okay. Then find this distance. Well, if I draw on the coordinate plane my right triangle, I know that this distance has a 1, 2, 3, 4, 5. Here's 5, so there's a leg, it's 5. 1, 2, 3, 4, and I have another leg of 4. So I'm solving for c squared, so I can use the Pythagorean theorem and then just plug in what I know. 5 squared or 4 squared, either one is a and b, equals c squared. Rounding to the nearest tenth, we're going to have to do. So 25 plus 16. 41 is equal to c squared, and then we have to take the square root to get c by itself. So we get 6.4 rounding to the nearest tenth. Whenever you're finding a distance, I don't want you to label it. If this doesn't have a label, it will be 6.4 units. Okay, so letter A, plot the point 1, 3, and negative 2, 4. So there's our point, and we would draw the triangle in between it. The y distance is 1, and the x distance is 3. So we're solving for our c distance. So again, the Pythagorean theorem, a squared plus b squared equals c squared. So 1 squared plus 3 squared equals c squared. This is 1 plus 9. So 10 is equal to c squared. Take the square root of 10, 3 point something. Square root of 10, 3.16, 3.2 units. So it's about a little over 3 boxes long, is what it's saying. Okay, so then there's something, well, what if we don't have a graph option? What if we don't have something that we can just graph 2 points and draw a triangle? Well, they have this thing called the distance formula. This is a vocab word. The distance formula, d, between 2 points, so here's my ordered pairs, is given by the formula d equals the big square root of x2 minus x1 squared plus y2 minus y1 squared. This should sound familiar. Remember, slope was y2 minus y1 over x2 minus x1. So the distance formula can be used to find the distance between 2 points on the coordinate plane. So where does this formula come from? I'll show you. That when we have this picture here, and that c is equal to our distance, or our distance between those 2 points. Well, to figure out, so we're going to plug it into the Pythagorean theorem. So we can automatically say that c is replaced with d. Well, a, to find this distance between a, that's on the x-axis. So a would actually be the difference between these two x's, so x2 minus x1, and then bring my square down, plus, I should have made more room. B is the distance on the y-axis, so y2 minus y1. Bring my squared along, and then now I'm going to rewrite that as that. Well, how do you get d by itself? Square root both sides. So the distance formula is really just the Pythagorean theorem solved using ordered pairs. And when you get to doing these problems, if you switch your x coordinates and your y coordinates, if you do all the y's first and then all the x's, that will work out just fine. So the order of these doesn't really matter, but ordered pairs go x and then y, so maybe that will help you remember x's come first. So we're going to write that every time here. Cromwell Field is located at this ordered pair and Drudeau Field at this ordered pair on some map. If each map unit is 0.1 mile. About how far apart are the fields? So we need to figure out the distance between these two. So distance is equal to the big square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Remember, this is x and y. So my x2 would be 1.5 minus 2.5 quantity squared plus 4.5 minus 3.5 quantity squared. So we get that this would be a difference of 1, negative 1 squared, plus 1 squared. Well, this would be 1. Negative 1 times itself is 1. 1 times itself is 1. So we get the square root of 2. So the square root of 2 units, 1.4. So our distance is 1.4 units. But it says that each map unit is 0.1 miles. So if we take this times 0.1, we actually get 0.14. And it's about 0.14 miles. It's kind of a weird situation there. So number 6 would be very similar. I'm actually going to skip that one. It's very similar to this one, just different numbers. And I will go down and practice these ones. Distance formula. D equals big square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Big square root x2 is negative 4. Negative 4 minus negative 5 quantity squared plus negative 2 minus negative 3 quantity squared. These minuses become plus. So we actually have negative 4 plus 5, which is 1. So 1 squared plus 1 squared, equals the square root of 1 plus 1, square root of 2, which from the above problem is about 1.4 units. Same as slide 5. Last one that we're going to practice, just so we're clear on these negatives. Distance equals the square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. x2, negative 4 minus 3.5 quantity squared plus 2.5 minus 1 quantity squared. Square root of negative 7.5 squared plus 1.5 squared. So anything squared is positive, so I'm going to leave off the negative. 56.25 plus 1.5 squared, 2.25, would give me 58.5. I'm going to take the square root of that. So square root of 58.5, not rounding until the end here, 7.6. So we get the distance is 7.6. We don't have anything, so units. So it's a lot of plug and chug. It's a lot of, you just need to learn what the distance formula is, and you just need to know that the ordered pairs go x, y. The only time you should ever look back is to see how far you've come. Have a great day.